Let's talk about data types and structures in R. One of the most common ones is the numeric data type. Numbers in R are treated as the numeric data type by default. You can use the function is.numeric to check if the data is numeric. Whole numbers are considered integers only when the letter L is appended. Using the function is.integer, we can see that 5 is not considered an integer, but 5L is. Similarly, append I to indicate imaginary and complex numbers. The logical data type is different in that there are only two possible values, true or false. Finally, the character data type is strings enclosed in quotation marks, single or double. If a number is enclosed in quotes, it's treated as character. Single quotes inside a pair of single quotes will give an error, and the same goes for double quotes. You don't have to cycle through all those functions to check the data type. You can just use the function class. We don't usually work with just a single datum. Rather, we work with data organized in various data structures. Vectors are the most fundamental data structure in R. It's a sequence of elements of the same data type. Here we assign a vector created using the function c to the variable example vector. You can add optional spaces after the commas for better readability. All elements in the vector are numeric, so using the function class will show the vector to be numeric. When creating a vector with mixed data types, all elements will be converted to the more flexible data type. For example, complex is more flexible than numeric because real numbers are essentially a special case of complex numbers. So numeric data will be coerced into the complex data type when these two are mixed. Logical values will be converted to 0 and 1 except when there is character data. Pause here and try it yourself. What happens when you create a vector with both logical and character elements? Factors are special vectors for categorical data. To make a factor, you will first need a vector. Here, we make a vector of character data named fruit.dat. Then we convert the vector into a factor using the factored function. The factor still stores the same data as the vector, but with the additional attribute of levels. Levels are all the possible unique values the data can take. Levels are stored in alphabetical or alphanumerical order by default. The order determines how the data will be visualized. If you want the levels to be displayed in a different order, you can add the levels argument and give it a vector with the level values listed in the desired order. Now it's the same data, but the levels are reordered. The order of these fruits is arbitrary. For ordinal data, though, where the order of levels is inherently meaningful, you can create an ordered factor. In this vector, small, medium, and large have a meaningful order, so we use the argument ordered equals true to make this factor ordinal. Data frames are probably the most common data structure. They're essentially tables where each column is treated as a vector. We can make a data frame from vectors using the data.frame function. The column names are the vector names by default, and you can rename them by using the column name equals vector format. Matrices and arrays are like two or more dimensional vectors in that they require all elements to be the same data type. We can make a simple matrix here by specifying the data 1 colon 6, meaning all whole numbers 1 through 6, and the number of rows and number of columns. The data are filled by columns by default. For arrays, you use the dimensions argument to specify the size. Lists are the most versatile data structure. A list holds a sequence of various data structures, from vectors to data frames and even lists. Here I'm making a list containing some of the variables we just defined. Similar to columns in a data frame, I can name the components of the list and specify the data. And then I'm making another list in which I include the list we just made plus a new vector. To retrieve or access individual elements in a data structure, use the square brackets in which you give the position or index of the element. You can also use the $sign to refer to a named component. In data frames, that would be a $sign followed by the column name. For two-dimensional structures like data frames and matrices, refer to individual elements by stating the row number, column number. Omitting the column number in this format retrieves the entire row. Omitting the row number retrieves the entire column. It would be similar for arrays, but with additional indices for higher dimensions.